Hello everybody and welcome to exercise 1 on page 132 of the workbook. And this is asking us to do some calculations in the inner product space C2, which is just two tuples of complex numbers. Okay, we're giving this the standard inner product, which remember is basically the dot product. And they're giving us a couple of vectors, x and y, and just asking us to do some calculations. All right, so let's start with the first thing that they'd like us to calculate, the inner product of x with y. And remember that the way that we defined that standard inner product was it had to do with taking components of x times complex conjugates of components of y. Okay, so we'd start out by looking at those two components and taking 1 plus I times the complex conjugate of negative 1. And then we'd look at the second two coordinates, okay, and take 2 times the complex conjugate of negative 2 plus I. Okay, and then we're going to work that out. So let's see, we've got 1 plus I. Complex conjugate of the real number negative 1 stays the same. Okay, and then 2 times the complex conjugate of negative 2 plus I is negative 2 minus I. Okay, and I'll leave it to you to actually distribute, kind of collect the like terms, and what you should come up with after you do the algebra is negative 5 minus 3I. Okay, and that's the result of the first calculation that they wanted from us. Okay, and then next thing they'd like us to calculate is the norm of x. Remember how that was defined? It was the square root of the inner product of x with itself. Okay, so now we're just focusing on x. So we've got a square root, and underneath we're going to take the inner product of x with itself, which means we are going to take the first component, 1 plus I times its complex conjugate, plus the second component times its complex conjugate. Okay, and then we need to work out the details and just see what we get there. So let's see, we're going to get 1 plus I times 1 minus I, and then 2 times its complex conjugate, that's just 4. All right, a little more algebra to do here. So we take 1 minus I and multiply it by 1 plus I. 1 plus I times 1 minus I, we're going to get 1. The middle terms are going to cancel out, minus I squared, and a plus 4 on the end. Let's see, what does this work out to be? We know from earlier that I squared is negative 1, so that 1 minus I squared is just going to turn into a 1 plus 1, which is a 2. And so after all that work, we end up with just the square root of 6. That turns out to be the length of x. Okay, and then the length of y, very similar calculation. Okay, let's leave out a few of the details this time. So we're going to get the square root this time of negative 1 times itself plus negative 2 plus I times negative 2 minus I. There's the complex conjugate. And I'll leave it to you to go through the algebra here, and you can confirm that this also works out to the square root of 6. Okay, so there's the norm of the vector y. Okay, and then finally, we come to the norm of x plus y. Before we do that calculation, let's see what the vector x plus y is. Okay, so we can see what x and y are up here. We just need to add those together. Okay, so we just do that addition component-wise. Let's see, we're going to get 1 plus I plus negative 1. The 1's are going to go away, and we'll just get an I in the first coordinate. And for the second two coordinates, 2 plus negative 2 plus I, we're going to get an I there as well. Okay, so there's what x plus y looks like, and therefore, the norm of x plus y, that's going to be the inner product of x plus y with itself, square rooted. Okay, so under that square root, we're going to take the inner product of I with itself, which is going to give us I times complex conjugate negative I plus I times complex conjugate negative I, and it just comes down to what that equals. Okay, so let's see, we've got a couple of negative I squareds, which interestingly both work out to be just 1. So we're going to get out a square root of 2 here, it looks like. Okay, and there's the length of x plus y, and we're done.